This is what I unaffectionately call the printerd. This is a Q3D 1-up that I received as a gift. It was a kit, and this was designed in 2014 as a $200 entry-level printer, and basically the physical characteristics of this machine have not changed since then. It's still being sold as a $200, sometimes more, printer. The website that describes its features is pretty much a bald-faced lie. Hopefully I don't get in trouble for saying what is my opinion on a YouTube site. But, you know, you've got exposed AC mains, you've got no box for your electronics, the hot end in there is just, it's a keyhole slot. It's just friction held. It moves around all the time. I've got wire holding it tighter. The entire frame of this thing is so sloppy and loose that you can barely keep it level to the bed. I had to make significant modifications to this in order for it to print once I was done with the assembly, and it still is kind of garbage. It doesn't print very well. The print quality is just never ever going to be good on this machine. So it's time to say goodbye to this machine. I don't need it. I have other printers that I can get much better results from. So my plan is to rebuild this faster, stronger, better. I think I can take these parts and build it into a much better frame and end up having actually a very functional printer when I get done with it. So that's the game plan. This is the last print this printer will ever make. Thank you for the learning experience. Moving on. So this is the game plan. I have these aluminum extrusion scraps that I put together to make a frame to replace this cruddy frame, and I think I can make it a little bit bigger in the process here. We're going to find out. But that is what I'm planning on turning this into this. So long, little guy. Wow, that's like really depressing. And just like that, it's done. It was much simpler than you would think. Okay, one of two things actually happened here. But it's highly likely that my daughter came upstairs and distracted me, and I totally forgot about recording while I was talking to her. Yeah, that's actually what happened. Anyway, so I have now several metric screws. I've got a couple of belts. I have 3 stepper motors, X, Y, and Z, and my extruder. This extruder is made out of MDF pieces that you just push together, and you run machine screws through the MDF to cut threads into it. Here, let me show you this. Here is my E3D E6 clone hot end, which actually did work fairly well. But the way you mount this is through this keyhole slot right here, is that you literally push it through there and slide it over like that. It's so wobbly. There's just no way for that to be solid and give you any kind of decent printing. Plus, the piece that it mounts to was just friction fit on there anyway. They just have tabs that fit in the notches. The whole thing, I had to zip tie so many pieces to get this thing to hold together. It was just such a joke. So I've got that. I've got an Acme lead screw. It's got a plastic nut. I could probably get a better nut for that if I want, but the plastic one actually will work fine for the Z-axis. I've got several 8mm rods of different lengths and linear bearings. Those are all good. Power supply. My Arduino 2560 with Ramps 1.4 board. Actually, this isn't the original one. The original one died. I had to replace it. So I have a decent amount of parts here to start building my new printer with. Okay, so to start off with, I'm going to try to do the easy thing first. So I've got my 6 sets of linear rails here, And because I'm trying to make this a little bit bigger, this actually used to be the Z-axis, these two large ones, but they will fit perfectly on this bed like this. So what I'm going to do is use those there instead of for the Z-axis, because this one is just about the height I'm going to need for the Z-axis. So I think that's actually going to work better for what I want anyway. And the lead screw is going to be about the right height as well. So the one thing I am going to have to do is that in order to make this a little bit more stable, what I'm going to do is take the bearings off these and add another set of bearings here. They're all 8mm rods, so it doesn't matter. But that'll give me a much more stable platform. A little bit less on the y-axis, but that'll give me a larger and more stable platform that I can use to for my y-axis. So what I'm going to need to do is design and print some brackets to hold these 8mm rods to my extrusion. So my plan here is simply to take my caliper and measure my extrusion width, 25mm, and the notch inside it, 6.5mm, and just bring that over to a piece of paper, draw that out so I know that I need something that will fit onto that piece but has a hole that will fit into the slot to fasten to the nut. So then I just kind of roughly sketched out here that if this is my shaft, and here I'm looking on this direction, that I want something that will hold on to that shaft, and this is from the end of the shaft view. So if I make a block that's split like this, goes around it, and then I have a bolt that goes through it into the extrusion, into the nut, that will both hold the block to the extrusion nicely and should clamp down on the shaft and keep it from moving. So that is my plan anyway. Let's see if I can sketch that out. Okay, I'm not going to go through all the mind-numbing minutia of trying to create a part like this, but I did. I'm going to print it out and see how it works. Well, I had some kind of thermal runaway problem, so it didn't actually finish printing, but it got within like the last couple layers, so that's totally fine by me. Don't care. So it actually does what I want it to do, to have a little bit of flex there. Let's see if it fits into the shaft. Shaft slides in fairly tight, and when I clamp it down, it's about the right thickness that I was expecting it to, so let's try to bolt it down. So that's the piece that is inside the extrusion track. So I simply have a bolt that goes through that, through the clamp, down into one of those nuts, and it's tighter than it needs to be, quite frankly. I mean, that's what I expected it to do, but this shaft is not going anywhere. It was pretty tight before I even started. And if I wanted it to look a little better, I could open that up more so it looks like that, and still this shaft is not moving in there. So I get one on the other side, get two of them there, and this is going to be rock solid. This is going to work really well. And just for fun, because all of my stuff usually looks like it was made out of Legos, I added a little 2mm bevel to, not bevel, what's it called? Fillet, there we go, to the edges here to make it look like it was more of a professionally designed piece rather than me screwing around. So we'll see how this turns out. Okay, so the one on the left is printed with the rounded edges, obviously, and the one on the right looks like crap. So I'm going to print more of these with the rounded edges. I think that has a little more professional look. Looks like I actually know how to use design software. But it printed okay the second time, so I think I'm going to stick with the same design in other aspects. So there's bracket 1 and 2. Looks great. I think these are going to work really well. So I also need to make some kind of bracket to attach these bearings to my print bed. So we'll keep working on that. Okay, so while those are printing,
I also need a way to attach my stepper motor to the y-axis frame so that it can move my bed along the y-axis. So, go back to my design software, design a bracket to hold the stepper motor, print it off, looks pretty good, actually lines up really well with my motor, fits on there perfectly, holes line up, should mount up very nicely right there. Find the right size 3mm screws because I save everything. That bolts up nicely.
Okay, without going through all the tedium of explaining, the process that I repeated for every single one of these, here are my rod mounts. I've got 4 of those that are holding the rods, and I also I used the mounting piece for the bed off of the old printer, trying to reuse as many parts as I can. So this will end up going here with bed leveling springs, so that'll be my full bed. The old one, I could really only use about 4 inches of it. It moved this way, and this one I'll be able to use almost the entire space now, with the exception of the little screws that'll stick up here. But so I've got a mount for attaching the belt to this, which I don't have attached yet, and I have I don't know what you want to call it. I've got my linear bearings on the inside the shaft there, and a lower and an upper piece that clamp this bracket down onto the bearings, and this is really smooth. This is going to work out really well, so happy with that. Let's see, I think I already talked about the motor mount. I'm going to end up putting a limit switch here, so when this bed bumps into it, it will become my limit switch. So I just need to attach my belt to this piece, and just using screws, screw this together, and we'll attach, where to go, this piece with the same pattern as the belt onto that, screw that down, that will pinch the belt there. And I've got, this is kind of low key, but it works. You cable tie the end of the belt, the teeth together, and put a cable tie between them, and then as the belt stretches, you can just use the cable tie to pull on that and adjust the tightness. You don't need any other mechanism. And if you need to remove the belt, you can just cut the cable tie and put a new one on. So that is it. Let's see. Oh yeah, this pulley here didn't exist. Had this from other stocks. That's one of the few pieces that isn't going to be. Oh, and this drive pulley here as well. Those are some of the few pieces that I had to add to this that weren't original with the machine. Okay, so here is where I'm at now. So I have my motor connected. I've got my end stop in place. So when my bed hits it, I can hold that. I've got my bed installed with my leveling screws and the springs and such. So, time for a test. So what I've got are the original electronics and power supply and a display that I added. So if I power this up, this should all work because I didn't do anything different with that. But in-stop works. So let's go to prepare and move axis. This is the Y. Hey, it works. Awesome. So that's it. Y-axis is done. Now, X or Z, which one do I want to work on first? I don't know, but it feels good to have this done.